Before we start today's musical Innertube, there's something you should know about Don.
Yes, yes, it's all true. I was a TV weatherman. Just look. We are going to see that rain move down and then just kind of stall a little bit. Let's take a look at our SkyTrack radar now. You can see the front almost running from Du Bois through State College, just north of us, and then down to Philadelphia. They have had some thunderstorms in Philly. That's why it's a little cooler than we are. But any place underneath this front is going to be hot and steamy for the rest of the night and into tomorrow. Let's take a look now at what it looks like from above. And you can see the satellite and radar. You can see the front right along here, and it's kind of buckling a little bit. Here's the heat. Here's the cool stuff up in New England. That front is going to turn into a stationary front, which means it's not going anywhere. And then eventually a warm front, and it'll start moving along. So the hot and muggy stuff will be here at least through Wednesday and into Thursday before this cold front can finally swing in and give us a little bit of relief. And that'll happen toward the end of the week.
Actually, Don, I'm kind of proud of you.
Really, John?
No, I'm just saying that so you'll feel better.
Well, I kind of do.
A heat dome is the popularized name for just a large region of unusual warmth. The scientific polar vortex is related to those cold air masses that sweep through. It's just another colorful way to blame the weather.
And now, we return you to the musical Innertube, already in progress.
What is this thing? What's this podcast?
Welcome to the musical Innertube. I'm Don Rooney.
I'm John Page.
We just talk to interesting people about interesting stuff. Well, weather has always been one of the great variables in everyone's lives. I mean, it dictates what we do, how we dress, where we go, and when we go there, how long we stay sometimes. Even with today's high-tech tools to forecast the weather, it's still pretty unpredictable. And on top of that, it seems climate change has thrown us all for a loop. Warmth is getting warmer, storms are getting stronger. All parts of the country and the world are being affected by the weather and how strange it's been lately. So today we're going to talk about all of this with meteorologist Jon Nese. He oversees the undergraduate program in meteorology and atmospheric science at Penn State, one of the prime places in the U.S. to study weather, I might add. Dr. Nese also oversees the Weather and Climate Communications Group, which is responsible for the production of the Penn State Meteorology Department's weekday weather magazine show, Weather World, in which they look at Pennsylvania weather every day and tell you what's happened and what's going to happen. So we got a pretty good guy to take us through all this. John, welcome to our world today.
Thank you very much, Don. Thank you, John.
Let's first of all go through some of the things that people are getting thrown at them now, some phrases that have been long in meteorology, but people are now experiencing them thanks to social media and to regular media outlets using them so much. And people will come up to me all the time because I did television weather for a little while, and I'm sure you get it constantly, and say, "What's this mean?" or "What's that mean?" So let's throw a couple of these terms out, and you can kind of define them for us. The first one is the one that nobody gets, and that is, what is La Nina and El Nino, and what are the differences between a La Nina year and an El Nino year?
These are phenomenon that to figure out whether they're happening, you go to the Pacific Ocean. You go to the Pacific Ocean near the equator. You go to the Pacific Ocean in the central and eastern part of the Pacific Ocean. So it's a narrow ribbon of water. And you simply ask a question. Are the waters in those areas warmer than average or colder than average? So you compute the average, and we have a network of buoys out there that can do that for us. And so you track temperature changes in those waters. And if those waters are warmer than average, above a certain threshold, we call it an El Nino. And if they are colder than average in those waters, we call it a La Nina. And informally, if it's close to average, we call it a La Nada. But that's a story for another day. So the next question, the follow-up is probably, well, who cares unless you live in those areas? And of course, the atmosphere is all interconnected. So when you change something in the tropical waters, you change the circulation in the air above, and that has repercussions into the mid-latitudes. And you can explain scientifically why certain things happen in the mid-latitudes. But just as an example, during winters when an El Nino is in progress, there's a pretty high chance that precipitation is going to be above average along the southern states. So I tell my students, later in life, when you have a second home in Florida and you invite me to come down for the winter, I'm going to check and see whether an El Nino or a La Nina is happening, because if there's an El Nino, it's probably going to be rainier than average in Florida. So that's what they are, and that's why they matter.
So something half a globe away affects what we do right here because everything's interconnected.
Right.
And I might add, just very briefly, what the jet stream is. That's one of the features that brings it to us. What is the jet stream?
Sure. Well, actually, the jet stream, there is a relationship between El Nino and La Nina and the jet stream, but fundamentally, everybody knows it's colder towards the poles and it's warmer towards the equator. And that temperature difference is responsible for creating the jet stream, which is a river of faster moving air, 5, 6, 7, 8 miles above our heads, that tends to move from west to east. And it tends to be situated over the middle latitudes, so somewhere between Canada and the southern United States, sweeping over to Europe. And it tends to move weather systems along. So we really care about where the jet stream is.
Now, what's the difference between a jet stream and you hear when weather gets really bad in California and there's a lot of rain, they say there's an atmospheric river. What is the difference between those two?
So there is a relationship. An atmospheric river is the name given to a stream of air that, although it doesn't have to impact the West Coast, it's used often in those contexts. So you have this stream of air coming out of the southwest, say from the vicinity of Hawaii, and it's just transporting all that Pacific moisture inland somewhere, often in the Pacific Northwest. But there can be atmospheric rivers that come out of the Gulf of Mexico and even that come out of the tropical Atlantic Ocean, bringing moisture to the east coast of the United States.
Yes, I just wanted to ask a question about La Nina and El Nino.
Sure.
Because you talked about a tolerance level, and I'm wondering how much change is effective? Like, how much change do you have to have under or over the average? And this is not because I'm making book in Las Vegas, but I just want to know,
Right.
what is that tolerance? Is it like 3 degrees warmer? Is it 10 degrees? Can you give us a sense?
Well, the waters never get to say 10 degrees warmer than average.
Right. Yeah.
That has not been observed in the record that I'm familiar with.
Sure.
But it's a great question in the sense that oceanographers and meteorologists identify varying degrees of an El Nino. So if that anomaly or that warmer than average tendency has to go through 3 thresholds. And the first threshold is about 1 degree Fahrenheit above average to define being officially in an El Nino. And then there are additional thresholds above that, a moderate El Nino and a major El Nino. So the meteorologists generally don't start talking about these things until you get to about a 1 degree a difference from average.
Yes, I just wanted to ask a question about La Nina and El Nino.
Sure.
Because you talked about a tolerance level, and I'm wondering how much change is effective? Like, how much change do you have to have under or over the average? And this is not because I'm making book in Las Vegas, but I just want to know,
Right.
what is that tolerance? Is it like 3 degrees warmer? Is it 10 degrees? Can you give us a sense?
Well, the waters never get to say 10 degrees warmer than average.
Right. Yeah.
That has not been observed in the record that I'm familiar with.
Sure.
But it's a great question in the sense that oceanographers and meteorologists identify varying degrees of an El Nino. So if that anomaly or that warmer than average tendency has to go through 3 thresholds. And the first threshold is about 1 degree Fahrenheit above average to define being officially in an El Nino. And then there are additional thresholds above that, a moderate El Nino and a major El Nino. So the meteorologists generally don't start talking about these things until you get to about a 1 degree a difference from average.
And the reason I ask that is that our instruments today are so sensitive, and in 10 years they'll even be more sensitive, that in conversation I'm trying to say, well, it doesn't take much because we don't think of a degree we probably can't tell the difference, if we put our finger in it, but you'll be able to tell. And of course, this is trillions of gallons of water.
Sure, it's a
You-
lot of
you-
we're talking about a lot of water here. We're not talking
exactly.
about one thermometer. We're talking about a huge piece within 5 degrees of the equator where these buoys are taking these measurements.
Thank you for that image of the guy in the boat sticking the
Yeah,
thermometer in. That's and then
me-
calling back to land. Hey, I
Right.
think it's a degree more. No, it's not that. It's actually this amazingly sensitive measurement that shows not only the interconnectedness you were talking about, but the fact that it's very sensitive, the whole setup that we have.
Well, and the impacts that one might notice, say in the United States, from an El Nino or a La Nina, they don't occur on a daily basis. You really have to look at the big picture, months to seasons, generally speaking. You can't blame a specific storm,
Of
for
course.
example, on El Nino or La Nina. So but a 1 degree change, if you're, say, studying thunderstorms over the tropical Pacific, there are certain thresholds that have to be met to get that cloud to just bubble a little bit taller.
Mm,
And so, yes, to someone studying thunderstorm development over the tropical Pacific, a degree can make a difference. Maybe you get a thunderstorm or you don't,
mm.
and that will determine whether these ripples that sort of ripple away from the equator and eventually alter the jet stream, it'll alter the probability of those things happening.
When you were talking earlier about colder at the poles, warmer at the equator, one of the other things that's been popping up during some particularly cold winters is the polar vortex. What exactly is that, and how does that change the weather in our United States?
Well, I'm going to go back to when I was a kid and it would get really, 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 really cold. And the meteorologist on TV, I used to watch, I'm from the Eastern Ohio, I used to watch Joe DiNardo and Bob Kudzma on the Pittsburgh television stations. And they would talk about an Arctic air mass just coming right out of the North Pole and plopping down into Pennsylvania and Ohio. And that's the way we talked back then. And then somebody discovered that we meteorologists have this term called polar vortex, which has been around since the 40s and 50s. And that sounds really scary and really colorful.
Yeah,
And it's
it's right
just,
up there with Snowmageddon.
well,
Yeah,
actually, I think that was a pretty clever, that was real. That was just a nickname given to a snowstorm. But
right.
yeah, it's just the latest. And my dad used to say bogeyman. I don't know if it's boogeyman or bogeyman.
I don't either.
The polar vortex is just another way to say it's going to be really, really, really cold. And a piece of that Arctic air that normally resides over the North Pole, but can sometimes dip into the mid latitudes where we live, is heading our way. But it does have a scientific definition. I just look at it as somebody discovered back in 2013 or 2014 that we had this terminology. And yes, the scientific polar vortex is related to those cold air masses that sweep through. It's just another colorful way to blame the weather.
Oh, definitely. And to go along with that, what we have now, and we have them with winter storms and summer storms, is this cyclone bomb.
Sure.
Again, what is that?
Once again, this is a real thing. It's simply a cyclone. The word cyclone is a synonym for storm, which
Mhm.
on the weather maps that folks might look at is just a low pressure system. It's an L.
Right.
And if one of those L's or storms uh, strengthens in a particular fast manner, for those of you who speak weather, it's 24 millibars in 24 hours, and I can convert that into inches of mercury if you'd like, but it's a certain strengthening rate. We call it a bomb cyclone. And these have been around forever. They happen all the time. Well, not all the time, but they're in any given winter. It frequently happens over the North Atlantic and the North Pacific. It's not like it's brand new, but it's, kind of sexy and colorful, and why not?
Yeah.
Why not? So now, generally speaking, you won't use that terminology in the summer for hurricanes. We don't. That terminology really only applies to the normal storms, the lows that you see on the weather map, not hurricanes.
Are there any other terms or things that people throw at you when you're in the supermarket and getting grilled about the weather, which I'm sure you do, that you've seen popping up recently that you didn't see maybe 5 years ago or something that people seem to know,
Hmm.
and you as a meteorologist go, how do they know about that? You know,
I guess that's a great question. As I think about some of the words that are used on television, not in the last 5 years, but I've heard the term debris ball,
uh-huh.
DEBRIS ball.
Yes, I've heard that too.
And maybe not in the last 5, and maybe the last 10 years, it's been popularized. And that simply means that when you look at on radar, and most people probably have a radar app on their phone where you can check where it's raining or snowing. If a tornado were to occur and lift debris into the air, that debris can be located on the radar image, and it has a certain look to it.
Huh.
And that look has been described as a debris ball.
Hmm.
My colleague, former colleague at the Weather Channel, Dr. Greg Forbes, who's now retired from the Weather Channel, would certainly popularize the use of that on television.
Sure.
One other one that's not recent, but which gets a lot of discussion is probability of precipitation. What does a meteorologist mean if he or she says there's a 50% chance of rain? And that one's still not necessarily widely understood. It's pretty straightforward. It simply means if for Philadelphia County, for example, there's a 50% chance of rain today, that means that at any given point in Philadelphia County, it, it would rain on 50% of the time such a forecast was issued. So you can't verify a 50% chance of rain by looking at one forecast. You would need to look at, for example, a set, perhaps 10 of them. And then if the forecast was accurate, it should rain on your home 5 of those 10 times.
Hmm.
So therefore, even a 20% chance of precipitation, if you interpret it that way, means that it will rain 2 out of every 10 times such a forecast is issued.
Yes, I think that as a practicing poet, or as a guy who at least likes to try to write poetry, I do love the language coming out of meteorology. I really do. Rain-wrapped tornado, for example.
Hey, you're welcome.
What a splendid! Did you make that up? Oh,
I
I
did
would
not.
like. Oh,
But
well,
I'm just, much like I have to take the blame for every bad forecast, I'm going to take credit for anything you give the profession.
hey, just lie because we won't know, okay? But seriously, that is so beautiful and such a mouthful, but it's an instantaneously graspable image, and that's the thing I like about meteorology is when it gets right down to it, it's where the rubber meets the road. It's where the rain hits your face and
Yeah.
the tree falls in your house, and there's a certain gritty reality to it, even though you have to use the language of science, which can sometimes abstract things, but still, in the end, what you're looking at. There's a reason, and Don will testify this because you're an old weatherman, Don. There's a reason people watch the weather, right? There's really concrete reasons. They have plans, they have cars, they have kids, they have
Oh, yeah.
schools. Yeah,
Definitely.
you know.
Well, let me, given your admission of being a poet, that polar vortex, there's some work been done to try to find out when that term first appeared in literature. And the best I've been able to find is a newsletter edited by Charles Dickens in the 1850s
Wow.
actually contains arguably the first mention of the term polar vortex. I got a real kick out of that.
Yeah,
Wow.
definitely. Wow.
Wow. Yeah, I'm a
Yeah.
big fan. I'm a big fan of Google Ngram, which can track the usage of words over time, at least in our printed material. And I'm going to look up polar vortex
Please,
when I get.
please do and get back to me.
Yes, I'd like to know because it's great to know that old Chuck made that one up. May I ask a question about Pennsylvania? For our listeners who do not know, your headquarters is pretty much in the center of the state. Talk to us a little bit about Pennsylvania as sort of a mega microclimate, as a place where different weathers happen.
Well, particularly during the swing seasons. We've had a couple days this month where it's been in the 80s in
Yeah.
southeastern Pennsylvania, in the 30s in northwestern Pennsylvania.
Yep.
Pennsylvania is in this middle ground between the equator and the pole, not right in the middle, but pretty close to it, where we truly experience the battle of the air masses. And
Mhm.
this is, in other words, if you're looking at a weather map, fronts are often in the vicinity of Pennsylvania. And, the word front was essentially usurped from World War I, where the front was the meeting ground of the different armies. And so a group of enterprising Norwegian meteorologists thought to themselves, well, the same thing happens in the atmosphere, that there are boundaries between air masses. And so Pennsylvania is always near this, not always, but often, particularly in the swing seasons, we're near this boundary, and that's where exciting stuff happens.
Ah,
Fronts are a place where air goes up. And as any meteorologist will tell you, where air goes up, clouds follow and precipitation follows.
Definitely.
So it's a matter of geography. Ohio's similar, Indiana, Illinois. And then you throw in Lake Erie,
mm.
just upwind. So when that wind blows off Lake Erie, neat things can happen. And then where does that air run into? It goes up into the Appalachians.
Right.
Oh.
And then for you folks in southeastern Pennsylvania, the wind will come down out of the mountains to you. And so you're on the sinking air side of things a lot of times. And sinking air generally dissipates clouds. So, you mentioned the central part of the state, John. There'll be days in the winter, I'm socked in clouds here, and Harrisburg's partly cloudy, and it's sunny in Philadelphia.
It's always sunny in
Except-
Philadelphia.
It's always sunny in Philadelphia.
A show.
Where have I heard that before? There's another phrase. And except, of course, if a low pressure moves off the coast,
Yes.
and then we get we get the winds coming off the water,
Yep.
and we're socked in, and it gets all those clouds bump up against the Appalachians on our side,
Yep.
and don't go anywhere. They can't get over the mountain. So,
And
yeah,
there are
we get
certainly-
socked in.
There have certainly been some storms in the last 15 years where it didn't do much in central Pennsylvania, but eastern and southeastern Pennsylvania got rocked.
Right.
So, and the thing that makes forecasting tougher there along that I-95 corridor is when you turn that wind coming in off the ocean. If you can blow air in off the ocean during the winter, that air has been moderated by the water, and it's generally going to be warmer than the air sitting over the land. So
Interesting.
exactly how that wind blows and how far in does that oceanic air get moves that rain snow line, and that puts Philadelphia often in a very precarious situation in terms of a very tough forecast.
I mean, people should recognize, and those who are not from around here, because we're in sort of have Philly as a mutual reference point. If it snows a lot in Philadelphia, a lot of folks have cars that are stuck for the season, and that's just because Philly is a town of alleyways and narrow streets, at least from the old days, which are all still here. And if it snows a lot, they can't get the snow movers in, and it's nobody's fault. They just ain't coming.
Right.
So it's actually, I mean, some towns are built for weather, and other towns are built the way they're built, and Philadelphia is definitely the one. I mean, even New York, yeah, it can get pretty much closed by a really bad snowstorm, but New York can dig out of it faster than Philly can. And it's the effects of really bad weather, as you say, on Philadelphia are remarkable.
And playing off of your use of snow here as kind of a bellwether, and to your original question about how diverse the weather can be in Pennsylvania, it's actually very rare. Let's use Pittsburgh, Philadelphia, say Williamsport, Harrisburg, and State College as 5 representative places in the state. I'm omitting Erie here because Erie's climate is so influenced by the lake during the
Right.
winter. But let's say there's a big snowstorm in Philadelphia, really big one, like a foot or more.
Yeah. Mm.
It's actually rare for each one of those other cities to also get a big snowstorm in that case. Stated another way, there are very few examples of a storm that produced a foot of snow in all of those places at the same time. That's how, big the state is, east to west, how, the mountains, proximity to the ocean. It's really, really hard to get a big one that hits everybody.
Now, let's also talk about when the winter storms come in and we get the nor'easters, and that is where a storm system is off the coast. It's because of the rotation of the wind around that, it is throwing air back from the water onto the land. And that's when you can get if it's cold in the land and that moisture's coming in, that's when you can get a real big snowstorm. So we've had in the past weather people who have said, oh, looks like we could get a foot or foot and a half, and the storm is off by just enough to give them like 3 inches or something like that. And everybody's mad at the weatherman because you said it was going to bury us and it didn't. Conversely, I don't know if this one's going to be good, and it hugs the coast and just buries it. So again, what is the variable there when we're talking about a storm coming up the coast as to whether or not you're going to get buried or you're just going to get a little bit?
Well, there are two ways I can approach that. One is you've already addressed. A difference of, say, 50 miles in the location of the center of the storm will move the heavy band of snow 50 miles east or west. And that's the difference between a foot in Philadelphia and a foot in Lancaster, or a foot in Reading, or a foot in Allentown. So, and the computer models that we rely on so heavily, although they continue to generally get better, there are still times when resolving exactly where that line is going to be is very difficult. A second train of thought here is that research has shown that in some of these big storms, there can be individual bands, perhaps only 10 miles wide, where the heaviest snow falls. And if you get under that band, you're going to get that high-end amount. And if you're on either side of the band, you're going to get a moderate amount. And predicting where those bands are going to be more than, say, 6 hours ahead of time remains really challenging. And this brings me to my final point. And this is one I feel passionately about. Although weather forecasting has gotten better, snowstorms come with this blend of, okay, is it going to be all snow? If it's not all snow, how much of it is sleet or freezing rain? If it's sleet or freezing rain, that's going to reduce the snow amounts. So there's this extra variable in terms of how, first you have to figure out if it's going to be all snow. And the public wants to know. The public wants to know as many days in advance as they want to know. And although forecasting has gotten better, beyond about 48 or 72 hours, I would take those total snowfall forecasts with a grain of salt. And I'm not sticking it to my own profession. I'm just telling you that snowstorms bring this unique blend of so many elements that you have to get right in order to get the snow forecast right. That, look, you got enough toilet paper. You probably have enough bread and enough milk. Okay? Wait till 48 hours or even 24 hours before the event. You're going to be fine. Jon, I heard you about digging out from snow. I heard you, my friend. Okay? But we're all going to make it.
Yes,
Okay?
absolutely, absolutely.
And so, but I do think that there has been this race, and Don, you've been in the TV business. You know what I'm going to say next. This race to be first.
Right.
Be the first one to put out the big numbers or the low numbers. And I get it. I get it. But the rate at which weather forecasting has improved on snowstorms has not kept up with the rate at which news directors want the forecasts that are given to the public to be out there.
Right.
And I'll die on that hill.
Yeah.
I think that so you've just brought up one thing that I think is really fascinating about your science, which is that it's so multifactorial, that you are juggling so many different stressors, so many different actors, and you'd need, a nation full of teraflop computers to
Well, we're getting there.
Yes, I think you're right. and I like the idea because it's the same in law. I can tell that people have watched now a lot of police professionals, and they expect crimes to be solved overnight. They expect all eyewitness testimony to be true. They expect a lot of things that just don't pan out in real life. You'd think an eyewitness testimony, first of all, would be reliable, and they don't fly all that well in court a lot. And here, to imagine that 4 days out, you could tell me exactly what's going to happen. I see your face, Jon. I know you've heard this before. You can't tell me what's happening on Friday? What's wrong with you? Is something broken?
And again, to Jon's point about news directors wanting to be first or tops.
Yeah.
In Harrisburg, we have four television stations rather that we look at. Everybody else gives a 7-day forecast, except for one in Lancaster that gives a 10-day forecast.
Okay.
Now, in a relatively mild area, like say maybe not where we are now, where the seasons are changing, but give it another month where there's going to be a string of 70-degree days. That's going to be pretty easy to do. But given in a situation like we are in March and April, where the seasons are changing, the winds can change, the temperatures can change. Like right now, it's 70-something in Harrisburg. Tomorrow, it's going to be 50-something. Again, a 10-day forecast to me seems like an incredible risk.
But let's make the distinction between the previous topic, which was snowfall amounts,
right?
The 7 to 10 day forecast, which when it's put up on the screen, yes, there are individual numbers there. And if you track the accuracy of those individual numbers, generally the farther out you go in time, the poorer the accuracy is. But generally, in many cases, 7 to 10 day forecasts, they'll pick up the rhythm. Okay, so it's going to be warm for a couple days, then it'll rain, it'll chill down for a couple days, then it'll rain again, and then it'll warm up. The rhythm is often correct. The timing is challenging, and the magnitude of the numbers is challenging. But I think you would be surprised much of the time if you don't look at the details, but if you just look at the trend. And we even do a segment on Weather World called 12-day trends, 2-week trends, which looks at days 8 through 14. So I'm looking starting 8 days in the future to 2 weeks in the future. And we don't give specific numbers. We just look at the trends. So it'll be warmer than average for a couple days, and then I think the risk of thunderstorms goes up. And there's actually some predictability even out to day 12, 13, 14 sometimes. So there kind of is a distinction between the snow amounts and the 7 to 10 day forecast. But if you don't mind, before we get off the snow topic, one other way to think about this. Let's say it rains 3/10 of an inch. Okay, 3/10 of an inch, whatever that might be, one day. And then it rains 8/10 of an inch the next day. Most people can't tell the difference. If I said, estimate how much rain that was, nothing against the
Nobody can
public,
do it.
but that's a tough one, okay?
Yeah.
Now, hold that thought, 3/10 versus 8/10. As a first guess, for every 10th of an inch of rain you get, if it was snow, that would be 1 inch. Okay, so now let's move to winter. Let's say 3/10 of an inch of precipitation falls, but it's all snow. That's 3 inches of snow. But if 8/10 of an inch of precipitation falls, that's 8 inches. Most people can tell the difference between 3 inches and 8 inches, and they'll let you know about it. Okay? So I think you probably get my point.
Yes.
A winter forecast adds this other element where people can tell the difference. Whereas if that was a summer forecast and it was just rain, people would be like, it rained. They were right.
Well, and this brings up another point, and that is we've had a very, very warm winter out west.
Yeah.
There's not a lot of snowpack. They're very worried because normally snow's pretty good in the upper elevations, the lower elevations of the Rockies out west. And then when that snowpack melts, there's the water that they're going to be able to use for the summer. Not happening. This is not the first year this isn't happening. And now we're also dealing with another one of these terms that has now come into popular usage, and that is heat dome. So what is a heat dome? How is that affecting the United States? And is that a long-term problem? Is that something that we're looking at dealing with for years and years?
Well, we've been dealing with heat domes since time infinitum. It's just nobody called it that.
Right.
I mean, a heat dome is the popularized name for just a large region of unusual warmth. Okay. And that's what we called it when I was a kid. Now, if you try to portray what this looks like in 3 dimensions and sort of shade in the area of great warmth, you can make it look like a dome. And it goes beautifully in 3 dimensional television graphics.
Right.
Okay. So I once again, I mean, it's okay. We use colorful language to get concepts across.
Sure.
I sometimes describe the jet stream as a fence, which is colorful and metaphoric, but it might not be the best scientific term. So we've been dealing with heat domes forever. Now, are some of the heat domes warmer than they used to be? Now, this is a place where the evidence is very strong that the fingerprint of climate change, you can do attribution studies and you can ask simple questions, such as, is the probability of this kind of thing increasing with time? And when it comes to these relatively large masses of warm air, I mean, this thing that just happened in March with the incredible number of record highs in the West and the central part of the United States, this is historic.
Hmm.
I mean, I haven't seen the final statistics yet on how many monthly records have been set, but there are places in the West where temperatures were so high in March that it broke the record for April. In other words, the number registered in March is higher than any number ever recorded in April. And so such occurrences are becoming more frequent,
Hmm.
and that, based on the scientific literature, is very likely related to a warming planet.
Okay, and so this could tie in with other things that we've seen that people have been complaining about, and that is snow as far south as the Carolinas.
Sure.
We had that this winter, and the fact that tornadoes, although technically I don't think we're getting more of them, they seem to be getting stronger. So am I on the right track with that, um,
Well,
or
actually, the literature that I'm aware of does not show that at all.
okay,
That the really high end tornadoes, the ones that get a label of 4 or 5,
right,
Yeah.
I've seen no evidence that they are more common now than they used to be. Actually, if you look at a graph of reported tornadoes going back to the 50s, it actually kind of goes up and and kind of starts to reach a plateau in the 90s. So it makes it look like something was going on, but the key word in that sentence is reported.
Yes.
Right.
In the olden days, a lot of tornadoes occurred, but nobody was there with a cell phone or the Doppler radar network wasn't in place, so we didn't really know they were there technologically. So the number of reported tornadoes has gone up, but that's only because, and research has shown that's mainly because it's the weak tornadoes that in the past we didn't even know were there.
Yes.
Now we know they're there and we're counting them.
Yes.
So yeah, and this actually is kind of a full circle moment because I hear a lot of people say, I've seen it written in large newspapers, that storms are getting stronger. And that makes it sound like all storms are getting stronger. But the evidence that all storms are getting stronger because of climate change is scanty at best. That is still very much a work in progress.
Right. Speculative.
mhm.
Yeah.
So the only thing that we can definitely speak to as far as what's being justified, shall we say, by the science is that the globe is getting warmer by degrees,
Right.
and whatever other weather ripples from that are still being studied.
Well, and there's a lot of work been done on hurricane frequency. I should acknowledge that. So these big storms that form out over the ocean, and Don, you'll appreciate this. They make for the best television
Yes.
because you could track them across the Atlantic.
Absolutely.
It's a 10-day story that just never ends, and it's very visual. So these big things, some recent research suggests that the stronger ones are getting stronger. at the high end. But ironically, it may end up being that in a globally warmed world, we have fewer hurricanes, fewer, but the high end ones are more high end. That's sort of where that research is leaning. So that particular aspect and the temperature aspect. What's really happening is that you're moving the distribution. So, temperature, for example, tends to be one of those quantities. If you plot it, it looks like one of those bell curves. It comes up in the middle, and that's just being shifted toward the warmer end. So there are fewer cold extremes and more warm extremes. That one, yeah, the climate change fingerprint is there.
I think it's really interesting that one of the things you mentioned is that one of the reasons that some of our readings are increasing is because we're just getting better at knowing stuff and detecting things.
Yeah.
And that's true across the board in science, that you have to rewrite the textbook and say, well, they probably were having a lot of tornadoes back when also.
Right. I wanted to be an astronomer. That's where I started, looking up at the sky.
Yeah.
When I was in school, I think Jupiter only had 12 moons and Saturn had 6 or something.
Right. Yeah. Those were the days.
What did I hear? Saturn has 72 moons? Who did
We're
that?
having moon inflation. Didn't you hear about that? My God.
And Uranus and Neptune have rings. What is
They
that all
do.
about?
I didn't know that.
I beg your pardon.
Isn't that cool, though, to think that science isn't just an encyclopedia of knowledge, that if you come up with a better observation, then the science changes.
Yes.
Right.
Yes.
And we saw that in real time during the COVID pandemic, where scientists were grappling with something that they didn't completely understand, and the science just evolved.
Oh my God, so quickly.
Some people suggested, well, the scientists lied to us. Well, I don't look at it that way. Science just got better.
Yes. Yes.
And when you find better science, you rewrite the science books. When science changes its opinion, it didn't lie to you before. It just learned more.
It was telling you the best it could before, it's like, gosh, the number of telephone calls in New York in 1860 is really low. What happened? You know what I mean?
Amazing.
Right, Don?
Oh, yeah. Yeah. And John and I were on the phone in 1860.
That's how it seems, doesn't it? Well, can I ask what a duration?
You do have a lot of archived episodes. I know.
We go back a number of years, John.
We really do. I have to ask, can you talk about derechos and what a derecho is?
Sure. Derecho is a high-end complex of thunderstorms that produces a swath of damage over, and I don't have the exact criteria memorized, but there is a criteria. So it's essentially a line of intense thunderstorms that produces a series of wind damage events, down power lines, for example, over a certain geographic distance, and with a certain number of winds above, I want to say, 75 miles per hour. So again, I don't have the criteria, but
that's fine.
To be officially a derecho, the line of thunderstorms has to do those things, and it's the kind of episode that you remember.
Yeah, definitely.
The one, I think it was 2012, June of 2012, went through DC, and it originated in northern Illinois and northern Indiana and came across the Ohio Valley and left people in the DC area. It was evening. That thing came through, and people were out of power for a week or more.
That storm you're talking about is the first place a lot of people got familiar with the notion of the derecho. That's really the source of a lot of the derecho chatter on the web.
And I believe that word, I'm sure you'll correct me if I'm wrong, has a derivation that means straight wind, meaning that the winds from a derecho will knock everything down in the same direction.
Interesting. Yeah.
Whereas winds of a tornado, given that there's a circular pattern, some of the trees will come this way and some of the trees will come this way, depending on where you are relative to the tornado.
And that was something that I found on television a lot, and that is a windstorm would come through, there'd be damage. People would say, "Oh, we got hit by a tornado," and I'd
Right.
say, "Let's wait for the National Weather Service to come by,"
Right.
because the National Weather Service would, within minutes, within hours, would send a team out to look and see what the pattern of the damage was. And if it was circular, then it was a tornado. If it was just straight down, it was straight winds.
Yeah.
And I had people calling up saying, "Well, I saw a funnel cloud." I said, "Well, then you're probably right. It probably was a tornado, but it's not officially going to be a tornado until the National Weather Service comes out and says, this pattern says we've had a tornado and what strength the tornado was, like an
Well,
F1 or an F5.
that funnel cloud, and that is real terminology, has to be in contact with the ground or it's
Right.
not officially a tornado.
Ah,
There are many instances when these funnel clouds appear beneath thunderstorm clouds, but the bottom of the circulation never really reaches the
gets
ground.
there.
Yes.
There's a lot of ways to think about that. There's some tornado theories that have the funnel developing upward, but the point is you need to have contact with the ground in order for it to officially be a tornado. And these days, as you pointed out, Don, the Weather Service will send out teams, and given that they probably saw the storm on radar, they know kind of where to look.
Right.
Mhm.
And there's so many amateur storm spotters these days who will basically say, "Hey, come down to the intersection of Branch Road and College Avenue, and that's where I saw the garbage can blowing."
Right.
Right.
Yes.
And so you have this ability to better pinpoint where to go. And then, of course, you send up the drones.
Right.
Yes. Right. Right.
So
Right.
it's,
And the weather balloons, which we still use to this day.
this is, you know where this is going. One day, everybody's going to have a barometer in their car, a pressure measuring device. And I know some of this is happening on small scales in some places. And you get all those pressure measurements being fed to the National Weather Service so you can get a better resolution on the pressure pattern or the temperature
Yeah.
pattern. I mean, this is coming.
The bottom line of it is number one, the weather patterns are changing and meteorologists are keeping up with that. And the second thing is actually it's probably a good thing that more people know what's going on, are
Yeah.
being educated in weather and why that's important to know. So
Yeah.
I think, John, you and your crew are doing as much public service as anything else.
Well, thanks. Certainly, the knowledge is power. And
Mm.
just something as simple as knowing the difference between a watch and a warning, which we didn't talk about, but the watch means the thing is possible. The warning is the upgrade, that it
Mhm.
is happening or it is imminent. So stuff like that, I like to tell when I go out to talk to third or fourth or fifth graders. I like to say, look, learn this and then go home and tell your parents.
Definitely.
Very
And,
nice.
as far as people saying, like a tornado warning will come up, immediately you're told to go to the basement or to a central part of your house. Um, People do this. The tornado actually doesn't wind up touching down.
Sure.
But the warning says that the conditions are right. And you can go into your basement 7 times out of 9 and nothing happens and you get all frustrated. But that 9th time, if you're in your basement and the tornado rips your house off, you're very grateful for having that warning in place and keeping track of what's happening.
Unfortunately, we're not in a very tornado prone state.
Yes,
Right. Not especially.
that's good. Well, John, thanks very much for
Fantastic. Thank you
coming
so
on
much.
and
My
giving us
pleasure.
all this information that is really needed and really appreciated. Thanks very much, John.
You're welcome. Happy to help anytime. Thanks for having me.
And thank you for listening to the Musical Innertube.
Send us an email at musicalinnertube, all one word, @gmail.com.
Or log into our website, musicalinnertube.com, and click on the microphone in the lower right-hand corner to leave us a voicemail.
And while you're on our website, take a few minutes to listen to past episodes of the podcast, along with pictures and biographies of our guests, blog posts, and lots more.
Our thanks to virtual band Car Radio Dog for providing us with our theme music.